Hello everyone, our next concept is module 2 theorems. Okay, why we go for the theorems even though we have nodal analysis, mesh analysis and KCL, KVL? Because if any complicated network is given, complicated network means if network contains many sources, many meshes, many nodes and many passive elements, if you want to find out response of any particular branch, then we use theorems. Okay, we have many theorems. In that, first one is superposition theorem, Norton's theorem, Thevenin's theorem, reciprocity theorem, and so on. Okay, in that first one is superposition theorem. Superposition theorem states that in a linear bilateral network, when many sources are acting simultaneously, the response of any particular branch is equal to algebraic sum of individual responses calculated by only one independent source acting alone. That means if circuit contains number of independent voltage source and current source, then we need to find out the response only one source acting alone. Okay, whenever I am discussing the problems, you will get better clarity about this concept. If network contains many number of sources, that is voltage sources and current sources, then if only one source acting alone and other sources must be switch off. Switch off means the voltage source is replaced by short circuit. Short circuit means the internal resistance of voltage source is 0, that is short circuit, and current source is replaced by open circuit. The internal resistance of current source is infinity. So we need to replace with open circuit and keep the dependent sources as it is. Keep the dependent sources as it is. And this theorem is only applicable for linear bilateral networks. Linear network means already we discussed in the previous class, that is resistance, inductance, capacitance, ideal transformer and linear dependent sources only. Next one, the presence of dependent source in the network makes it active. Then superposition theorem is applicable for both active and passive networks. Superposition theorem can be applicable for both active and passive networks. Linearity means here we have two properties, that is first one is additive property or superposition property. Additive or superposition property. This means if input is x of t, then the response or output is y of t. If input is x1 of t, then response is y1 of t. If input is x2 of t, if the response is y2 of t, then according to additive principle or superposition principle, x1 of t plus x2 of t gives y1 of t plus y2 of t. Okay, this is called additive or superposition principle. Next one, second principle is homogeneity. Next one is homogeneity. Okay, in this homogeneity, so if response is multiplied by k1, that is x1 is multiplied by k1, then y1 is multiplied by k1. If response is and second response, that is second input, if input is multiplied by k2, that is second input, then response is multiplied by k2. According to homogeneity principle, k1 x1 of t plus k2 x2 of t is k1 y1 of t plus k2 y2 of t. Okay, this is called homogeneity principle. If circuit elements satisfy this homogeneity principle and this additive principle, then element is linear element. Okay, so that is 1 plus 2 is equal to linearity. There is one important note point. Okay, what is the note point? In a linear network, if excitation is multiplied by constant k, the response of all branches also getting multiplied by some constant k. That means suppose if there is a linear network, okay, n by w means network. If there is a linear network, here the input is 20 volts, that is excitation means input. Here input is 20 volts and the response or output is 2 amperes. If the input, that is excitation, is multiplied by some constant k, I am multiplying this with 3. 3 means 3 into 20, you will get 60. This is 60 volts. So the response of all branches, so here the response is 2 amps. Response means output. This is also getting multiplied by same constant k, that is 3. So you will get 6 amps. Okay. Based on this concept, we will see one example. Let us consider this circuit. Here this is linear network. Okay, in between dotted lines, this is linear network. So this is excitation. Now find the response of all branches. Okay, find the response of all branches. I am taking here, it is V1. If you apply nodal analysis at V1, or you can write or write the node equation at V1. So nodal analysis at V1. So what is V1? V1 minus 20 by 3 plus V1 by 4 plus V1 by 4 is equal to 0. If you solve this, you will get V1 is equal to 8 volts. Okay, 8 volts means the voltage across this resistance and this resistance, because these two are connected in parallel. So here it is 8 volts and this is 8 volts. Now what is the current flowing through this branch? So V1 by 4. V1 by 4 means this is 2 amps. Here also this is 2 amps. This branch current is 2 amps. Now here by KCL, what is the current? This is current. So by KCL, this is 2, this is 2. So totally you will get here 4 amps. So the voltage across 3 ohms is 4 into 3, 12 volts. Okay. Now I am multiplying this excitation with 3. If you multiply this excitation with 3, you will get 60 volts. So same network I am representing here. This is 60 volts. Now find out V1, or you can take V2. Same, write the node equation at V2. What we are getting? V2 minus 60 by 3 plus V2 by 4 plus V2 by 4 is equal to 0. If you solve this equation, you will get V2 is equal to 24 volts. Okay. So if you observe here, in this case, this is 8 volts. If you multiply this 8 volts into 3, you will get 24 volts. So here this is V2. V2 means the voltage across this 4 ohm is 24 volts. Here also 24 volts, because these two are connected in parallel. Now what is the response? That is current. Current flowing through this branch is V2 by 4, that is 24 by 4, 6 amps. Here also you will get 6 amps. Here by KCL, this is 6, this is 6. So you will get 12 amps. If 12 amps current is flowing through this resistor, so what is the voltage drop? Here current is leaving, so it is minus. Here current is entering, it is plus. So by Ohm's law, 3 into I, 36 volts. Okay. If you observe these two circuits, if you multiply this 12 into 3, you will get 36. If you multiply this 4 into 3, you will get 12. If you multiply this 8 into 3, you will get 24. Again this 8 into 3, you will get 24. 2 into 3, 6. 2 into 3, 6. That is, in any linear network, if excitation is multiplied by some constant k, all responses are multiplied with same constant k. In the next video, we will discuss problems on the superposition theorem. Okay, thank you for watching.